Section 1.3 was all about particles of matter, and more specifically, how our understanding of these particles of matter has changed over time. In order to talk about and to review Section 1.3 today, I'm going to use the Padlet that we worked with before spring break. You'll notice that I've added a little bit to it. I'm hoping that that helps to bring the whole conversation together a little bit better. I hope it makes it easier for this to understand. If you have questions after this video, remember that we have our Google Hangout session this afternoon. You're welcome to log into that and to ask more questions. We'll also be meeting, or you'll have the option to meet in the Google Hangout again on Wednesday, same time. So way back when, in 440 BCE, a guy named Democritus coined the term atomos, and he used it in reference to a particle that he said was so small that it couldn't physically be cut any more than it had been. And that was sort of the beginning of atomic theory. That was the beginning of our conscious thoughts about an atom. So if we were to take everything that we knew back in 440 BCE and boil it down, all we know at this point is that an atom is the smallest particle that exists. So that is how they would have drawn a picture of an atom conceptually way back when in 440 BCE. Now we also know from our lesson that in 440 BCE there was another philosopher that was super famous named Aristotle, and Aristotle didn't really buy into this idea of atomos, this idea of an atom. And because they didn't have a good way to test theories back then, it was more an argument that was hypothetical than an argument that was scientific. The greater community really respected Aristotle, and so they decided that he was right and Democritus was wrong. So we end up with this really long period of history between 440 BCE and 1803, where the conversation about the atom really stalled, where we didn't hear anything new about it. So for over 1,000 years, this dot is what people thought of, if anything, when they considered what is an atom. Now in 1803, a guy named John Dalton, a scientist, continued the conversation a little bit, not so much because he was curious about atoms, but because he was curious about compounds. He was curious about how matter might combine to form new substances with new properties. And as he was testing all of these different questions regarding compounds, he ended up learning about the atom too, and he published an atomic theory in 1803. Remember, the word atomic just means referring to atoms. So his theory about atoms was made up of 3 parts. The first part was that all substances are made of these things. They're all made of atoms. They're small particles, just like Democritus thought. They can't be created, they can't be divided, they can't be destroyed. John Dalton also thought that atoms of the same element looked exactly alike, and that atoms of different elements all looked different from one another, that these atoms could join. There's this idea of compounds as well to form new substances. So if we were to boil down the idea of an atom in 1803, it would go from looking like a single dot to perhaps looking something more like this picture here. Now we understand that all atoms are different. So the atom that forms the oxygen that we breathe is different somehow. We're not sure how yet, but it's different somehow from the gold perhaps that we have in our jewelry, the atoms that make up that gold. So we thought of atoms still as just tiny little particles that couldn't really be created or destroyed, but they're all different and they can combine. So there's something interesting happening here beneath the surface. We're just not sure what yet. Fast forward now just shy of 100 years, and we end up with another scientist named J.J. Thomson in 1897. Now, J.J. Thomson decided to study atoms in more detail, and through all of his experiments discovered that there was a part of the atom that had a negative charge. Normally when we think of negative and positive charges, we're thinking of things like magnets, right? We know that a magnet has a negative pole and a positive pole, and the positive and negative sides of a magnet like to click together, and the negative sides of 2 magnets like to pull apart or repel apart. Same with the 2 positive sides if you try to put them together. So he used that understanding of magnets to discover that there was a part of an atom that had a negative charge. He called those tiny negative charges in an atom electrons. So as of the dawn of the 19th century, as of 1897, this is a pretty accurate model of what the scientific community thought of when they thought of an atom. So we have this tiny particle, again, that can't be created or divided or destroyed, like John Dalton was saying, but then sort of sprinkled in the middle of that, we know that there's some negative stuff somewhere. That's it, but we've made some progress. Now we fast forward just shy of 15 years to 1911, and another scientist named Ernest Rutherford made a couple of pretty profound discoveries. So now we know that those negative particles exist thanks to J.J. Thomson. Ernest Rutherford discovered that in addition to those negative particles, atoms have positive particles as well. Ernest Rutherford called these positive particles protons. So now we know that inside an atom there are negative and positive pieces. And Ernest Rutherford proposed that those positive pieces, called protons, lived in a tiny, very dense ball at the center of an atom, which he called the nucleus. So he discovered not just protons, positively charged particles, but Ernest Rutherford also discovered the nucleus. So as of 1911, when Ernest Rutherford had finished his studies, we ended up with an atomic model, a picture of an atom that looks something like this. Notice we have our nucleus in the center, and then we have all of these negative particles, which we are calling electrons already at this point in history, floating around the outside. So if you'd asked a scientist in the early 19th century, what does an atom look like? This is the picture that they would have drawn for you right here. Now, at this point, people were on the scent. They knew we were getting close to what is actually happening inside of an atom. And so we noticed that there are a lot of discoveries that suddenly start to take place, one right after another after another. So we only have to fast forward about 2 years to a scientist named Niels Bohr to see the next big development in our atomic theory, in the way that we think about what an atom looks like. Niels Bohr took this idea of electrons floating around a nucleus, and he organized it a little bit more. He published a new atomic model that basically just said that these electrons aren't randomly floating around. They're organized in energy levels, and each energy level, Niels Bohr said, could only hold a certain number of these negatively charged particles. For instance, the first energy level, the one closest to the nucleus in the center, can only hold 2 electrons. Niels Bohr also said that the second energy level, the one outside of that nuclear ring, could only hold 6 electrons, and then we built out from there. So Niels Bohr proposed that in addition to what we know about the parts of an atom, there's also some sort of an organization to this atom, perhaps, too. Now we fast forward a little bit more to the mid-1900s, so now we're dealing with about 1950, 1960, and 2 additional scientists named Schrödinger and Heisenberg developed what we call our current atomic theory. Now, Schrödinger and Heisenberg didn't dispute that this is sort of what an atom looks like. If you asked a scientist even today what does an atom look like, they're going to draw you a picture very similar to Niels Bohr's model right here. However, they did have a little bit of a bone to pick with what Niels Bohr said about these electron energy levels and exactly where an electron is going to be. It's true that the protons and the neutrons float around in the nucleus, and it's true that the electrons rotate around the outside, and they take up a lot more space than the nucleus, which is very dense and packed. But Schrödinger and Heisenberg proposed what was called an electron cloud, which is basically just a region, a zone where electrons are floating around in patterns we can't completely understand yet. We can't pinpoint exactly where an electron is going to be all the time. However, what Niels Bohr proposed with these energy levels only holding a certain number of electrons, he might have been onto something with that too. We'll notice more about where that comes into play when we talk about the periodic table. So from 440 BCE all the way through to the mid-19th century, we see that a lot of growth and a lot of change has happened in the scientific understanding of the atom. In the review assignments that you have to choose from for today, a couple of your options involve creating models of atoms. So if you choose to take on one of those projects, like creating a model of a carbon atom, for instance, you're probably going to end up with an atom that looks something similar to what Niels Bohr published in 1913. You'll end up with a nucleus that has protons and neutrons, and you'll end up with electrons and energy rings around the outside. If you choose to model the compound, now you're going to want to take a step back. You're going to want to scale out a little bit more. And at that point, you can think of each atom as looking a little bit more like this. You can think of each atom as sort of being a single part, and you can focus in on how those parts are going to connect to other parts, sort of like John Dalton was when he proposed his atomic theory in 1807. So if you have questions on this, please drop by our Google Hangout this afternoon. If not, best of luck and have fun on your projects. We'll chat again soon.